So today we are going to be solving an interesting trigonometric exponential equation. We have two equations given. The first equation is a normal trigonometric equation and it is sin x plus sin y equals to 3 upon 2. Now the second equation is a trigonometric exponential equation and it is 2 to the power sin x plus 2 to the power sin y equals to 2 plus square root of 2. Now the question over here is to find the value of x and y in the range of 0 degree to 360 degree that will satisfy both of this equation. So this is Anmol and now let us see the solution. How can we solve this problem? Okay, now let us start with the solution. So the first thing that I will do is I will take this first equation and subtract sin of x on both of the side. So when I will do so, I will get the value of sin of y equals to 3 upon 2 minus sin of x. So here we have ultimately got the value of sin of y in terms of sin of x. So now what I will do is I will take this second equation and in this I will replace the sin of y with its value that we have just got. So the second equation will now look like 2 to the power sin of x plus 2 to the power sin of y. Now instead of sin of y I will put its value, that is 3 upon 2 minus sin of x, and this thing equals to 2 plus square root of 2. Now to simplify this equation we are going to use an exponential property, that is a to the power m upon a to the power n equals to a to the power m minus n. If the thing is like this way, it can be turned into this, and if the term is in this form, it can be written like this way. So this property we are going to utilize in this term. We have 2 to the power 3 upon 2 minus sin of x. So that is in this particular form, so we can change this thing in this way. So on doing this change, this thing will turn out to be 2 to the power 3 upon 2 divided by 2 to the power sin of x. Okay, now 2 to the power sin of x, all the remaining terms as it is. Okay, now to further simplify this equation very nicely, what I will do is I will simply substitute 2 to the power sin of x with a variable a. So now let us do these changes over here. Therefore a plus 2 to the power 3 upon 2 divided by a equals to 2 plus square root of 2. All this term 2 to the power sin x has now been replaced with a. Now if I simplify this equation by taking the LCM and doing the cross multiplication, the equation will look like a square plus 2 to the power 3 upon 2 equals to 2 plus square root of 2 multiplied with a. Now concentrate on this particular term, that is 2 to the power 3 upon 2. So this thing can be written as 2 to the power 3 the whole power 1 upon 2, and this thing will ultimately square root of 8, and that is 2 square root of 2. So 2 to the power 3 upon 2 is ultimately 2 times the square root of 2. Now let us rewrite this equation by doing this particular change and shifting this term from that side to this side. Therefore this equation will now look like a square minus a times 2 plus square root of 2 plus 2 square root of 2 equals to 0. Okay, so now we have this equation and it is a quadratic equation, and to simplify this thing all you need to do is you need to open this particular bracket. So when you will do so, this equation will look like a square minus 2 times a minus square root of 2 times a plus the remaining term as it is, that is 2 square root of 2 equals to 0. Now what I can see, from these two terms I can take a common, so inside the bracket a minus 2. From these two terms I can take negative square root of 2 common, so inside the bracket a minus 2 equals to 0. Now from these two terms I can take a minus 2 common, so the other bracket will contain a minus square root of 2, and this thing finally equals to 0. So now we have the product of these two brackets equals to 0. So either this bracket is equals to 0 or either this bracket is equals to 0. So when we take a minus 2 equals to 0, the value of a comes out to be 2. And when we take a minus square root of 2 equals to 0, the value of a turns out to be square root of 2. So these are the two values of a that will satisfy this equation, and that is ultimately this equation, and that is again this particular equation. This means a equals to 2 comma square root of 2 ultimately satisfy this particular equation. Now how we got this equation? We got this equation by substituting 2 to the power sin x equals to a in this equation. So as we can say, 2 to the power sin x is equals to a. The values of a are 2 comma square root of 2. This means the value of 2 to the power sin x is also equals to 2 comma square root of 2. Now let us compare this solution one by one. So first of all I will compare it with 2. So 2 to the power sin x equals to 2, that can be written as 2 to the power 1. The bases are same, hence we can compare the power. Therefore sine of x equals to 1. Now let us compare the above equation with square root of 2. So 2 to the power sine x equals to square root of 2, that can be written as 2 to the power 1 upon 2. Again the bases are same, hence we can compare the power. Therefore the value of sine of x will turn out to be 1 upon 2. Now it was given that we need to find the value of x and y in the range of 0 degree to 360 degree. Okay. So here we have sine of x equals to 1. We know this particular fact that sine of 90 degree is equals to 1. And no other value from 0 degree to 360 degree will give us 1 except 450 degree, and that is after 360. So the only solution possible is 90 degree. So sine of x equals to sine of 90. On comparing this equation, the value of x will turn out to be 90 degree. So here we have got one of the values of x. The reason I told one of the solution because this equation is still pending to be solved. So sine of x equals to 1 upon 2. Now I know this thing that sine of 30 degree is equals to 1 upon 2, and the other value between 0 degree and 360 degree in which sine gives us 1 upon 2 is 180 degree minus 30 degree, that is 150 degrees. Okay, recall that on the plane this is 0 degree, 90 degree, 180 degree, 270 degree and again 360 degree. So on this complete rotation we need to find the solution for sine of x equals to 1 upon 2. So we know this thing that sine is positive in the first quadrant and in the second quadrant. Now as the value of sine of x was positive, so the solution in the first quadrant we got 30 degree. Now the other solution possible would be in the second quadrant. So to get this thing we can simply subtract 180 degree minus that angle. Okay, this is the basic you must know. Okay, so the other solution possible over here is sine of 150 degree. So sine of 150 degree is also 1 upon 2. So in comparing sine of x with sine 30 and sine 150, we can get the value of x equals to 30 degree and 150 degree. So finally the values of x are 90 degree, 30 degree, 150 degree. So I'm writing that thing over here, x equals to 90 degree, 30 degree and 150 degree. And the possible values for sine of x were equals to 1, 1 upon 2. Okay, so here we have got the value of x. Now let us try to get the value of y. So recall this equation, sine of y equals to 3 upon 2 minus sine of x. So we have two values of sine of x, that is 1 and 1 upon 2. So when we put that values, the value of sine of y turns out to be 3 upon 2 minus 1, that is 1 upon 2. 3 upon 2 minus 1 upon 2, that is 1. So these are the values for sine of y, that is 1 upon 2 and 1. Therefore the value of y will turn out to be again the same thing, that is 30 degree, 150 degree and 90 degree. Now let us write down the final answer as the table. So sine of x and sine of y. When sine of x equals to 1, sine of y equals to 1 upon 2. When sine of x equals to 1 upon 2, sine of y equals to 1. Now let us write down the final table for x and y. So when x equals to 90 degree, this means the value of sine is 1. Now according to this, the value of sine of y should be 1 upon 2. Therefore the possible values of y turns out to be 30 degree and 150 degree. Similarly, when sine of x equals to 1 upon 2, therefore the value of x equals to 30 degree and 150 degree. Therefore the value of y turns out to be 90 degree. So the final pairs of solution are like this way: 90 degree, 30 degree, 90 degree, 150 degree, and 30 degree, 90 degree, 150 degree, 90 degree. These are the four solutions for x, y in the range of 0 degree to 360 degree that will satisfy both of these equations, and this is the answer that we were looking for. So this was my way to solve this particular problem. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment, you can email me or else you can send it to me on my Instagram. The link is in the description.